Hello, my name is Simon Balean, and I am doing my fuel science project on alternative sources for crude oil. Crude oil is a naturally occurring, unrefined petroleum product composed of hydrocarbon deposits and other organic materials. Crude oil can be refined to produce usable products such as gasoline, diesel, and various forms of petrochemicals. Advantages of this is that it's one of the most abundant energy resources. It's practical because it's easy to transport and use, and oil has a very high heating value, which means the amount of energy and heat released when fuel is combusted. Also, it is relatively inexpensive. According to the United States Energy Information Administration, the United States produces around 8.8 million barrels per day. And consumption has also been increasing, especially due to Donald Trump's new energy policy, where he expunged tax credits for renewable resources. Disadvantages is that this fossil fuels take billions of years to form. It's a finite resource. According to Ecotricity, oil is projected to deplete at 2050, gas at 2060, and coal at 2090. Also, oil endangers environment and ecosystem, and the burning leads to a lot of carbon emissions. This is because combustion of petroleum emits a variety of pollutants such as carbon dioxide, carbon monoxide, sulfur dioxide, nitrogen oxides, and volatile organic compounds. These pollutants are directly and indirectly linked to climate change, acid rain, and public health issues. As one of three fossil fuels, oil has less carbon content than coal, but more than natural gas. But because it's a biofuel, my proposed solution is algae fuel. But because it's a biofuel, it's essentially carbon neutral because the carbon emitted when it's burned has just recently been absorbed as food, which means that the net CO2 emission is essentially the same as if the algae had never been grown. That does not include CO2 utilized in production. Industry claims that algae-based biodiesel has a GHG footprint that is 93% less than conventional diesel. Some algae production is sited near sources of CO2 such as power plants in a kind of symbiotic relationship. The cultivation of algae as a source of fuel is a rich and varied field of research. Studies have shown that certain species of algae can produce up to 60% of their dry weight in the form of oil. The algae can be processed into crude oil that is visually as well as metaphorically green. Although algae release CO2 just like traditional fossil fuels, when they are burnt, the CO2 is taken out of the atmosphere by the next crop of growing algae. So bio-based fuel with essentially carbon-neutral combustion, it's drop-in replacement for petroleum-based liquid fuels, and is inherently renewable. It absorbs carbon dioxide as it grows. Both waste CO2 and wastewater can be used as nutrients. Higher energy per acre than other biofuels, and it can be grown on land suitable for other types of agriculture. This is also scalable, as a study showed that 17% of U.S. oil imports can be met with algae. Production is presently scaling up, and research has been underway for around 50 years. The disadvantage is that it needs to be grown under controlled temperature conditions. It requires a considerable amount of land and water, and it has relatively high upfront capital costs, and the fertilizer has potential environmental effects. In summary, algae-based biofuel is a promising energy source that is in the latter stages of development. A number of issues related to the ultimate cost of the product needs to be resolved, but there is a good deal of research money going into this as production is beginning to scale up. Land issues can be addressed using marginal land, water can be recycled in reactors, cold flow issues might result in the fuels being blended with other fuels or possible additives, and fertilizer issues could be addressed using waste streams, thereby recycling the critical nutrients. Time will tell, though I believe this is an important technology to watch. Thank you for your time.